So now let me give you some demos on the things that I have talked about, like lock timeout, like isolation level and deadlocks. Okay, so for this, I'm going to use an example where, let's say, I have an application A and I have another application B, and they are trying to access rows from this table, which is, let's say, the employee table that is part of the sample database. So that is the employee table. There are many columns on the table. I only put two: employee number and first name. And we are going to use two rows in particular. So I have not put more rows than that. But let's say application A is doing an update. So let's open as well two windows. So I go start run. And then I type db2cmd. I'm opening one command window at the top. So let's say that is application A, and I'm going to do the same thing here. Run db2cmd, and I open another application B, and from Linux it will be the same thing, but you can open two terminal windows. Now from each of them I'm going to connect. So from the application A, I'm going to say db2 connect to sample. So I am going to connect to the sample database. From here I am also going to connect to the sample application connected, both of them to the sample database. So one on the top is application A, the one at the bottom is application B. Now what I'm going to do is I copied this to Notepad, so it is easier for me to perform these operations. So from application A or command the line processor window number 1, I'm going to do the following. I'm going to do, let's say, an update, and then I'm going to do an update on the row with application A is trying to access or do an update on the row with an employee number of 50, and it is going to, because it is going update, it is going to take an XLOC, an exclusive lock. Okay, now I'm going to do that by running this statement. So I execute this statement, and note that I am using the flag plus C. That means do not commit. So for example, for this particular application, which is the db2 command window, there are several flags, and the plus C means do not commit because this particular. Application auto commit, so I want to prevent from auto committing because I don't want to release the lock. So I am going to press enter, and the statement performs successfully, and the lock is held. So right now what we have is this application, for example application A, which is the first command window, and this takes the next lock. Now what we are going to do is we are going to go to the other application, and we are going to run an update, but on another now, which is row number 30. So basically from application, as you can see, the application B, we are going to do an update on this particular row. So we're also going to take an XLOC, exclusive lock, because I am doing an update. So we do an X here as well. Now let me run that from this window here, and I press enter. As well, I am using that plus C, which means do not commit. So now I have two applications that two updates on different rows. Therefore I have exclusive and exclusive over here. So now the first thing we are going to look at is we are going to see a timeout situation. So from the command line window number 1, I'm going to run this statement db2 plus C again. So I am not auto committing, and issue a select first name. from employee where employee number equals to 30. So basically from the first application within the same transaction, because I am not committed, that means it is still the same transaction. What I'm doing now is I am doing a select on this particular row. So basically I'm taking a shared lock. A shared lock here. Now because the application B was taking exclusive lock on this row, then this other application A will have to wait. So it will hang and hang in there. So let's see the behavior here after I press enter here. So I press enter and you see the prompt has moved to this side, to the bottom. So now it is waiting and waiting, and is basically going to be there forever, because as I showed you before, there is a parameter lock timeout. By default is set to -1 and I have not changed that infinite wait. So this is the timeout, and because lock timeout was set to -1, I have to wait forever. I set to 30 seconds and I will get an error message. Now I'm going to kill deselect, and I'm just going to do a control C to interrupt. I'm going to interrupt this control C and I'm going to run the same query again, but I am going to add with UR. So basically for this particular SQL, I'm going to say that I want isolation with UR, because otherwise by default this application is using the cursor stability or CS. Okay, so it is the same scenario, but now I am saying with UR and press enter, and look, I do get the result even though the locks are being held taken. Let's see from this chart, even though there is an exclusive lock over here, now I'm going when I'm saying with UR, then there are no locks taken here at all. So this can go in and read the information. So there is no shared lock, and you can read the information. Let's say on using with UR for isolation on one particular statement. Let me go back and remove this with UR and try again. And again you will see it will hang. So we will leave it like this, and now I'm going to move on with an example, but this time we are going to do a select, but on row number 50. And this is going to be done by the application B. So basically this is application A, this is application B, and now what we are going to do is this application is we are going to do a select on this row, and because we are doing a select, basically I'm trying to get a shared lock. I'm getting a shared lock here, but what I just caused is basically a deadlock, right? Because one application is waiting for the other one hand for a resource, and application B is holding a resource, and application A is holding the other resource. So what is going to happen is we just created a deadlock. So let's execute that SQL statement from this other window. Right click, so let's do it again, and I'm going to press enter here. And what is going to happen is probably will take about 10 seconds or so, and then one of the application will roll back and the other one will be happening, right? The one at the bottom was rolled back, so application 2 or application B was rolled back, and here is the application, the current transaction has been rolled back. Because of a deadlock or a timeout reason code 2, and the other one was allowed to continue. So I got here the right result, which is the first name, which was Sally for this particular employee number. So this is the other demonstration I wanted to show you with respect to deadlocks, and it took about 10 seconds because it is based on the parameters. deadlock. Check time, which I mentioned to you before, and this parameter basically says if you set 10 seconds, it means that DB2 will check every 10 seconds if there is a deadlock. So every 10 seconds, is there a deadlock? Every 10 seconds, is there a deadlock? And so on and so on. So anyway, you can try and practice this scenario yourself.